Imagine looking at a meadow full of flowers. You see red poppies, yellow dandelions, white daisies, a beautiful sight. But if you were a bee, you'd see something completely different. Flowers would glow like neon signs in ultraviolet. Invisible patterns would appear on the petals, leading straight to the nectar, and the red poppies would look black to you. Bees see the world in a way that's hard to imagine. Their eyes work on completely different principles than ours. Today we'll look at the world through a bee's eyes. A bee has 5 eyes. Yes, 5. 2 large compound eyes on the sides of the head and 3 small simple eyes on top. The compound eyes are true engineering marvels. Each consists of about 5,000 hexagonal lenses called ommatidia. Each ommatidium is a separate light receptor that registers a tiny fragment of the surroundings. The bee's brain assembles these thousands of fragments into one image. It's like a mosaic made of 5,000 tiles. The image isn't as sharp as ours, but it has other advantages. The 3 simple eyes on top of the head don't serve to form images. They measure light intensity. They help the bee orient in space and maintain stable flight. They work like a gyroscope. The biggest difference between a bee's vision and ours is the range of visible light. We see colors from red to violet. Bees don't see red. For them, a red flower looks black. But they see something we cannot: ultraviolet light. Ultraviolet opens up a completely new world for bees. Flowers that look single-colored to us have complex patterns in ultraviolet. Lines, circles, arrows. Scientists call them nectar guides. These patterns lead the bee straight to the nectar. It's like runway markings that guide a plane to the landing strip. The flower literally tells the bee where to land. Evolution created a perfect communication system between flowers and bees. Flowers advertise in ultraviolet, and bees have eyes to see those advertisements. The relationship between flowers and bees has been co-evolving for over 100 million years. Flowers that developed better ultraviolet patterns attracted more bees and produced more seeds. Bees that could read those patterns more accurately found more nectar and raised more offspring. Over millions of generations, this mutual pressure shaped both the flowers we see today and the eyes that see them. It is one of the most beautiful examples of co-evolution in the natural world. The implications go beyond beauty. When we plant ornamental flowers bred purely for human aesthetics, flowers with no ultraviolet patterns, no nectar guides, no scent, we are removing the signals that bees depend on. From a bee's perspective, such a flower is invisible. It offers nothing. Understanding how bees see the world is not just fascinating science. It is practical knowledge that can help us make better choices in our gardens. Bees see colors, but their palette is shifted relative to ours. We have 3 types of color receptors, responding to red, green, and blue. Bees also have 3, but they respond to ultraviolet, blue, and green. This means bees see colors we can't even imagine. Mixtures of ultraviolet with other hues create shades for which we have no names. At the same time, bees can't distinguish red from black. That's why red flowers like poppies often have ultraviolet patterns to attract bees, despite this. Interestingly, bees see blue, violet, and yellow flowers best. That's why these colors dominate among bee-pollinated plants. A bee's eyes have one more remarkable feature. They see much faster than ours. The human eye registers about 60 frames per second. That's why a movie in the cinema looks smooth. A bee sees about 200 frames per second. That's more than 3 times faster. For a bee, our movie would look like a slideshow, but this speed is essential in flight. A bee flies at 30 kilometers per hour, dodging obstacles and landing on swaying flowers. It needs lightning-fast image processing. If a bee saw as slowly as we do, it would crash into every branch. Fast vision is a matter of survival. This high frame rate also helps bees track moving targets. A flower swaying in the breeze, a rival bee approaching the hive entrance, a predator lunging from a hiding spot. All of these require rapid visual processing. The bee's compound eye, with its thousands of individual lenses each pointing in a slightly different direction, gives it an almost complete view of its surroundings with no blind spots. It is nearly impossible to sneak up on a bee. The trade-off for this speed is resolution. A bee's visual image is far less sharp than ours, but sharpness is not what a bee needs. It needs speed, breadth, and the ability to detect motion. Evolution gave it exactly that. Bees have one more visual sense that we don't possess. They see the polarization of light. Sunlight passing through the atmosphere becomes polarized. It creates patterns in the sky invisible to the human eye. But bees can see them. This allows bees to navigate even on cloudy days. Polarization patterns indicate the position of the sun even when it's hidden behind clouds. It's like a built-in compass. This ability is crucial for forager bees. They must precisely return to the hive after multi-kilometer expeditions. Polarized light, combined with the sun's position, allows them to navigate with remarkable accuracy. Carl von Frisch, who discovered the bee dance, was the first to prove that bees see polarization. He received the Nobel Prize for this discovery. Bees assess distance in a unique way. They don't use stereoscopy the way we do. Their eyes are too close together for that to work at greater distances. Instead, bees measure distance using optical flow. They observe how quickly the image moves across their retina. The faster it moves, the closer the object. That's why bees fly more slowly in narrow spaces. Fast image flow from both sides signals that they're close to obstacles. In open space, they speed up because the flow is slower. Scientists have used this knowledge to build drones. Some drones navigate exactly like bees, measuring optical flow instead of using GPS. Bees solved the navigation problem millions of years before us, and we're only now learning from them. The world seen through a bee's eyes is completely different from ours, full of ultraviolet patterns, polarized light, and 200 frames per second. Bees don't see better or worse than us. They see differently. Their vision is perfectly adapted to what they need. Finding flowers, navigating in space, and avoiding threats. Every flower you pass on a walk hides patterns invisible to you, patterns that bees read like a map. If this episode opened your eyes to the world of bees, leave a thumbs up. Subscribe to Hive Mind to discover more secrets of nature. See you in the next one.